Okay, the first thing we're going to do with polar graphs is find the slope of a polar graph. So using the conversion equations that x equals r cosine theta and y equals r sine theta, we're going to come up with the slope, which is dy dx still. So using the idea that we learned before with parametric, dy dx was dy dt over dx dt, but in polar form it will just be dy d theta over dx d theta. So your third parameter here is theta. Okay? So let's go ahead and take a look at this cardioid, 2 plus 2 cosine theta from 0 to 2 pi. So dy dx is going to be dy d theta over dx d theta. And what we're going to do is use our conversion equations. So I'm going to go ahead and start with x equals r cosine theta. So in order to come up with dx d theta, I want this equation to be just in terms of x's and thetas. My r is given as 2 plus 2 cosine theta, so I'm going to go ahead and substitute that in there. So x is really 2 plus 2 cosine theta times cosine theta. Now I'm going to go ahead and take the derivative of this. So dx d theta is going to be, you can either leave it like this and do the product rule, multiply it out. I'm going to leave it like this. The derivative first is going to be negative 2 sine of theta times the second plus the derivative of the second is going to give me negative sine of theta. So I'm going to change that to a minus times the first. So there's my dx d theta. dy d theta is, we're going to do the same way. I'm going to use the conversion equation y equals r sine theta. Again, replace that r with 2 plus 2 cosine, so y is really 2 plus 2 cosine theta times sine of theta. So again, using this equation, take my derivative of y with respect to theta. Derivative first is negative 2 sine theta times the second plus the derivative of the second is cosine of theta times 2 plus 2 cosine theta. Okay, so now I'm going to take these two equations and do dy d theta over dx d theta, and I want to know what happens at theta equals pi over 6. And if you plug in pi over 6 and simplify your answer, you should get negative 1 as your slope. Okay, next, same questions that we've seen before. At which point, find the points at which the tangent line is horizontal. So go back to your slope. Tangent line is horizontal means that dy dx is 0, which in this case really means that dy d theta is equal to 0. So I'm going to take dy d theta and set it equal to 0. I'm going to simplify this out a little bit, multiply it out. I get negative 2 sine squared theta plus 2 cosine theta plus 2 cosine squared theta equals 0. Now at this point, this is all your pre-calc skills. We're going to have to simplify this out, try to solve this quadratic. I noticed that I can divide everything by a negative 2, so I'm going to clean this up a little bit. Sine squared theta minus cosine theta minus, cosine squared theta equals 0. I can't factor this at this point because I've got sine squared and cosine squared, but I have this extra term with the cosine, so that's my clue that you want to change the sine squared to be cosines. So I'm going to do a substitution 1 minus cosine squared theta for that. Everything else stays the same. And I'm going to combine like terms. I get 2 cosine squared theta plus cosine theta minus 1 equals 0. I have a quadratic. Let's factor 2 cosine theta minus 1. Cosine theta plus 1 equals 0. I get theta equals pi thirds and 5 pi thirds. And theta equals pi. Now they do ask you for the points. So in polar form you want r and theta as your points. So you want to plug these thetas back into your r value here. And the points that you will get is 3 comma pi thirds, 3 comma 5 pi thirds, and 0 comma pi. But if you think about the graph of this cardioid, this graph looks like this. Notice that 0, it's actually a cusp, but that is not a horizontal tangent. So I'm going to go ahead and cross that out. Okay. Last part, tangent line is vertical. So that means dy dx is undefined. The bottom being 0 would really mean you're looking for where dx d theta is equal to 0. And again, I'm going to take dx d theta set equal to 0. I'm going to combine like terms and clean it up a little bit. I get to this. I'm going to divide by -2. Factor it out. And I'm going to get theta equals 0, pi, 2 pi thirds, and 4 pi thirds. Again, I'm going to go ahead and take these points, plug it back into your r to find the corresponding r. So my points are 4, 0, 1, 4 pi thirds, 1, 2 pi thirds. And again, I'll get that 0 pi, but that's this point right here on your graph. That is a cusp, that is not a vertical tangent. Okay, so look at your graph and it should make sense. Oh yeah, I have 2 places where I have a horizontal tangent. There are my 2 places. I have 3 places where I have a vertical tangent. 1, 2, 3. So that makes sense just by looking at the graph.